A 4-year-old can launch an app with 2 swift swipes. We are conditioned for instant digital gratification, driving how we consume information today. In response, corporate learning and development teams now heavily promote microlearning as a mandatory innovation to keep pace with digital natives. But designers often treat it as a universal fix. They assume that simply making content shorter automatically makes it effective. Swapping comprehensive training for bite-sized content breaks down structurally if you ignore cognitive load and strict taxonomic limits. Sound microlearning is a parameterized architecture. It is strictly bounded by 4 established learning theories and 3 distinct learning domains. We are going to define the exact thresholds where this format succeeds and exactly where the architecture collapses under its own constraints. Mastering these specific thresholds is essential for sound instructional design. Microlearning is a delivery mechanism, and it relies on 4 established paradigms of how the human brain acquires and retains data. The first is behaviorism. Learners acquire knowledge through conditioning and feedback loops. In the 1950s, B.F. Skinner introduced teaching machines based on operant conditioning. These machines presented information in small segments, required interaction, and provided instant feedback, a direct mirror of modern microsegments. You see this today in flashcard apps. The user inputs an answer and receives immediate correct or incorrect cues, reinforcing the desired response. The second paradigm is cognitivism. Instead of passive conditioning, the learner actively processes, chunks, and encodes information for later recall via observation. A healthcare app sending diabetic text reminders applies this perfectly. By using bolded typography for crucial stats and mnemonics like glucose bad, the design forces the brain to create associative recall. Third is constructivism. Learners dynamically build comprehension by testing what they know against their environment and engaging in role play. A pharmaceutical rep can watch a short training video, pause it to script their own response to a doctor's objection, and then hit play to compare their script against the actor's performance. Finally, connectivism prioritizes the network. It focuses on the ability to access specific nodes of knowledge at the exact time of need, rather than storing everything in internal memory. A customer service rep doesn't need to memorize a complex return policy. They just need to pull up a micro-reference guide while the customer is on hold. Together, these 4 theories transform short-form content from passive observation into a scientifically grounded intervention. Moving from how we learn to what we learn, we encounter the 3 learning domains. We start with the cognitive domain. Cognitive growth scales from basic memorization up to critical thinking, a progression measured by Bloom's taxonomy. This data matrix maps Bloom's taxonomy against micro-learning viability, establishing strict limits on what a short module can achieve. The viable zone covers remembering, understanding, and applying. Consider active shooter preparation. A single 1-day workshop often fails because learners cannot reliably recall critical procedures 100 days later during a high-stress event. Replacing or augmenting that workshop with a monthly micro-campaign, like brief barricade demonstration videos or localized exit inventories, effectively sustains that low-level recall over time. But the format fails at the levels of analyzing, evaluating, and creating. High-level synthesis requires a massive cognitive load. You cannot teach an employee to draft a complex business proposal through a series of 2-minute snippets. Microlearning prevents knowledge decay. It cannot build complex cognitive schemas from scratch. The second category is the affective domain. This governs emotions, attitudes, and the adoption of corporate values. This taxonomy table maps the affective thresholds to determine where short-form influence stops working. The viable zone here allows you to move a person from receiving a new concept to valuing and organizing it. Brief, emotionally charged testimonials or internal celebrity endorsements successfully influence these foundational levels. The failure state is championing. Believing in a value so strongly that you actively advocate for it requires sustained social constructivism that a brief video simply cannot engineer. The final category is the psychomotor domain, the link between mental processing and physical motor skills. Dave's taxonomy maps the physical training thresholds, outlining the progression from basic observation to automatic movement. The psychomotor safe zone is restricted strictly to basic imitation and manipulation. A field technician diagnosing and swapping a specific malfunctioning machine part using animated GIFs fits perfectly within these bounds, but the method hits a hard wall at precision, articulation, and naturalization. Physical mastery requires prolonged, targeted practice. Observational content is not a substitute for muscle memory. Across all physical tasks, microlearning acts as a spark or a guided reminder, not as the engine for internalized mastery. This dynamic alignment reveals a consistent structural boundary where microcontent reaches its functional limit. Before building content, designers must define the foundational theory, isolate the specific domain, and map the taxonomy level to ensure an effective use case. Blindly substituting long-form macro training with bite-sized modules destroys instructional efficacy and leaves learners entirely unprepared for complex synthesis. Microlearning is a precision instrument. Its entire utility lies in foundational processing and recall sustainment. By offloading basic recall and reference tasks to these targeted modules, you free up intensive macro environments, like workshops and apprenticeships, for deep synthesis and complex problem-solving. Microlearning succeeds when it is applied to the specific taxonomic levels it was built to support.